Hey guys, sorry I'm late. I've literally been home now for about 30 seconds. I'm sorry I got home a little later than I thought I was going to, but I'm here so we can start talking about math now. My dog is coming in here and she wants to play. Um, okay, so we have been off for. Sorry about that. We have been off now for a couple weeks, and I know sometimes we forget some things. So we've been doing some review in class, and I just want to review a little bit on here too. And then at the end, we're going to talk a little bit about the problem of the week for this week. So if you're here, again, ask any questions on Google Classroom or on YouTube. I'll try to look at both of those. So without further ado, we'll start on the top. So today in class we were talking about adding together fractions. Now, one thing about when we add fractions is keep in mind that we need pieces that are of the same size. So if we're adding fourths and twelfths, those are like apples and oranges. Those sizes are completely different sizes. So in order to put them together, we need to have sizes that are the same. So one thing that we can do is that we can make common denominators. So in this case, I have 6 3/4 and 7 5/12. So one thing I'm going to do is I'm going to make a common denominator. We had talked in class about listing multiples of each denominator. So for instance, we could list multiples of 4s. We could list multiples of 12. If we do that, here we're going to figure out that the common denominator is 12. So for this first one, I'm going to write 6 because that's my whole number, and I'm going to write down twelfths below that. And for my second number, you'll notice that it's already twelfths, so I'm just going to keep it that way. Now, I might ask myself here, well, we know that 4 times something is 12. Well, what is that number? Well, we know that 4 times 3 is 12. Whatever we do to the bottom of the fraction, we have to stay consistent and do it to the top so that we don't change the fraction at all. So we're going to take 3 times that 3, and we're going to figure out that 9/12 is equivalent to 3/4. From this point, now that we have pieces that are the same, notice we have twelfths and twelfths. We're dealing with pieces that are the same size. So now all we have to do is add. What I'm going to do is add my whole number, 6 and 7. 6 plus 7 gives me 13. And I'm going to add my fraction. 9/12 plus 5/12 gives me 14/12. Now, one thing I know about 14/12, and we talked a little bit in class today, is that it is an improper fraction, meaning that the top, the numerator, is larger than the bottom, the denominator. When that happens, we know that our fraction is more than one whole. For instance, in this case, it would only take 12 of these pieces to be one whole. What I mean by 12 of those pieces is if I say that 12/12, this fraction right here, that would be equal to one whole. We have 14/12, meaning that we have more than one whole. So what I'm going to do is I'm going to say, well, 12/12 of this is one whole. So I'm going to change this 13 to a 14. But since I transformed 12/12 of that into a whole, I need to figure out, well, what's left? Well, 14 minus that 12 that I took away gives me 2 12th pieces left. Now, one thing you may notice when you get to this point is if you get two numbers that are both even numbers, you can always divide by 2 if they're both even numbers. I always like to look at this first number and I see, well, 2 is a prime number. If 2 is a prime number, that means that the only numbers that can divide 2 are 1 in itself, which is 2. So I know that I can divide 2 by 2, and I can also divide 12 by 2. So if I divide each of those by 2, divided by 2, divided by 2, that's going to give me 1/6. So my final answer here is going to be 14 1/6. Same idea for this second one. I'm going to leave that second one to you guys. In the second one, you don't get an improper fraction in the end, so it's actually a little bit easier than the first one. But see if you can make the common denominators in that second one and do the same idea. Let me check messages real fast. All right. So for the next part, we're looking at different types of numbers. Sometimes we're looking at two fractions. Sometimes, in both of these cases, we're looking at a fraction and a decimal. There's so many ways that you could figure out when one number is larger than another, and I'm going to show you a few right here. For this first one, we have a fraction and we have a decimal. Now, some people just like working with fractions better. Some people just like working with decimals better. I like them both at different times. So in different cases, I might choose to do a different strategy. In this case, I see this 2/5, and one thing I know about 2/5 is that it's pretty easy to change into a decimal. Keep in mind, our decimal place values are 10, are tenths, hundredths, thousandths, 10,000s, 100,000s, millions. So as long as I can get this denominator into one of those, it's easy to make into a decimal. So I know a really easy thing to change fifths into is tenths, because a fifth is double the size of a tenth. So I know that I can just multiply this by 2. Whatever I do to the bottom of that fraction, I'm going to do to the top, which gives me 4. Now, just by that, by making 4/10, I can easily change that into a decimal. When you get to decimals, like we have here, so we have 4/10 and we have 63/100, it's really easy to compare two decimals because they're the same type of number. One thing I like to do here is, since there aren't any hundredths, remember we can actually put a 0 in the hundredths place because it's a little easier to compare hundredths with hundredths. So from that point, all you have is 63/100 versus 40/100. When I say prove it here at the end, that is exactly what we just did. I mean, do something that shows me which number is bigger, and by changing them both into decimals, we did that. Now, I could easily do the same thing here if I wanted. I could change 8/9 into decimals now, into a decimal. Now, 8/9 is a little bit harder to change into a decimal. Keep in mind, this is going to be a repeating decimal. This 9 here is not going to, we're not going to be able to change that into a 10, 100, or 1,000, meaning that this decimal is going to go on forever. One way to figure that out, remember this line in the middle means division. So that's like saying 8 divided by 9. So if I wanted to figure out what that was, the decimal, I could literally just put 8 divided by 9, add a decimal and a 0 here, and it would look something like that. And I could figure that out, what that decimal was, and then compare it to 75/100. In this case, I'm going to show you a different way you could also do this, just to give you a couple options. What I like to do here is I like to look at this 75/100, and I was thinking, well, could I turn that into a fraction? Keep in mind, when we've talked about a number line, we said that if we had a number line, we said if this is half in the middle, sorry, it's not a good view, that's half in the middle, and if this is whole over here, directly in the middle of that is 75/100. And we've said that a fraction that is equivalent to 75/100 would be 3/4 or 3/4. So I know then that 3/4 is the same as 75/100. So what I'm going to do is I'm just going to say, well, that's the same. Now that I know that 3/4 is 75/100, I have two fractions here. One easy way to figure this out would be to find a common denominator between 3/4 and 8/9. Once I've done that, I can figure out which number is bigger. So keep in mind there's multiple ways to do this. A third way, let me erase this a little bit, that I might do this is by using a little bit of logic. Same idea to start out. I know that 75/100 is 3/4, and I have 8/9. Notice that each of those fractions are missing exactly one piece. 3/4 is missing 1/4. 8/9 is missing 1/9. If I asked you which one is closer to being a whole, well, 3/4 is missing a whole fourth. 8/9 is only missing 1/9, which is a really small piece, which means that it's closer to a whole. So 8/9 would be the larger number. So there's a lot of different ways we could prove 8/9 is a larger number, prove it, but one of those ways might work for you. All right, let's flip to the back side. Let me check one more time to make sure no one's asking any questions. Keep in mind, guys, if there's something that you're just like, man, I don't get this, tomorrow morning come in, tomorrow during class, ask questions. We'll keep going over things as long as we need to until we make sure that everybody has it, because that's the important part. So come and ask. I will definitely go over it with you if it's something that you're struggling with. Lunch too. Lunch, I will be in class. All right, so we have a bunch of numbers here. Today in class we talked about how I don't usually, sometimes I'll label the number lines. Yesterday and today I didn't label the number lines, which means that you can label them with whatever you want. Yesterday we had a number that was greater than one whole. Today we don't have that. So today, if I were you, I would label this number line to go from 0 to 1. And I would make your marks for 1/2, 1/4, and 3/4, just because those help to figure out where these numbers go in a number line. It's important not to just know how these numbers would fall in order, but exactly where they would fall in comparison to other numbers. So keep in mind, the number line and labeling it like this is pretty helpful. So I'm just going to go across first, and I'm going to put my decimals on the number line, because generally people think those are the easiest to put down. So I know that 1/2 is 5/10, and I know this here is 75 hundredths, and I know this here is 25 hundredths. What I'm going to do is I'm going to start off with 682 thousandths. I look at that number in the tens place and I see a 6. So I know that that number is larger than 1/2. But at the same time, it's smaller than 75 hundredths. It would fall somewhere in the middle, a little bit closer to 75 hundredths. So what I'm going to say is 685 thousandths would be about there. Just like that, you're done with one. Don't try to do all of these at a time. Try to do one at a time, and that'll make it a little bit easier. Next, I'm going to try 46 hundredths. So 46 hundredths has a 4 in the tens place. Keep in mind that 50 hundredths would be half. So that's just a little bit smaller than that. It's bigger than 25 hundredths. It's close to a half, but it's not quite there. So I'm going to write 46 hundredths right there. Now, the rest of these numbers we're left with are fractions. So I know that some of you guys don't really like working with fractions. So keep in mind, you can change these fractions into decimals. But there's strategies we can use to make them a little less scary. So one thing I'm going to do first is I'm going to look at all of these numbers, and I'm thinking in my head, which ones of these are larger than half, and which ones are smaller than half. So I'm looking right from the start, and I'm thinking, well, what is half of each of these denominators? So I look first at the 3. This is probably the hardest one to figure out, because 3 is an odd number. Half of 3 is 1.5. So 1.5 is bigger than 1, so I can say that this number is smaller than half. Here, half of 12 is 6. This is 7/12. That's bigger than half. I'm just going to circle it. This next one is 5/8. Half of 8 is 4. 5 is bigger than 4, so I'm going to circle that one. And this last one, half of 12 is 6. 6 is bigger than 3. So that one is smaller than half. So just based upon that, I know that these two numbers right here are going to go somewhere on this side of the number line. And I know that the other two numbers are going to go somewhere on this side of the number line, which is pretty important. So I'm going to start by, I'm going to do 2 of them for you, and then I'm going to give 2 of them to do on your own. So the first 2 I'm going to do are the ones that are smaller than half, which would be 1/3 and 3/12. Now there's a couple things we could do with 1/3. Keep in mind that this here is 1/4. I know right from the bat that 1/3 is a little bigger than 1/4 because they have the same numerator, but 1/3 is split into fewer pieces, so the pieces therefore are bigger. I know it's bigger than 1/4, but I have to make sure that it's smaller or bigger than 46 hundredths. One thing I might remember is if I divide 1/3 out, it is the same as this decimal 0.33 repeating over and over. So what I'm going to do is I'm just going to put, I know that's a little smaller than 46 hundredths, so I'm just going to put 1/3 as a little bit bigger than 1/4. It's pretty close in size, but it's a little bit bigger. The other one that I have to put here is 3/12. Now, 3/12 is, it looks unfamiliar, but it's actually not quite as unfamiliar as you think if you simplify it. Now remember, when we say simplifying something means making it as simple as possible. One way to do that is we could look at the top and bottom number and we could say, is there any number we could divide each of those by? I always try to use the top one if possible. So in this case, we have 3/12. I would divide the top by 3. I would divide the bottom by 3, and 3/12 is equal to 1/4. So then I know that 3/12 is going to go in the same place as 1/4, right there. Sometimes fractions look unfamiliar, but if you change them around a little bit, they're more familiar than you might think. They just look a little bit different than you're used to. Now, these last two, 5/8 and 7/12, I'm going to tell you something about them, but I'm not going to quite give away the answer. Notice that both of those are pretty close to a half. 7/12 is just 1/12 bigger than a half, and 5/8 is just 1/8 bigger than a half. So I'm going to let you try to figure out which one of those is bigger. You know they're both around a half. One strategy that might be helpful is to use common denominators. Try to use common denominators and see if you can figure out which is bigger there. All right, which leaves us to the last question. The last question says, Kennedy won the lottery and bought 10 different McDonald's restaurants. That sounds really good. Since she loves all the 5th grade students so much, she decided that she would give all 96, although I think we have more than 96 now. I'm gonna have to change my future word problems. We got a couple new students. All of them a Big Mac and a Shamrock Shake. If a Big Mac costs $3.59 and a Shamrock Shake costs $2.59, how much will it cost Kennedy to give all this food away? So we know that one Big Mac costs $3.59. I would know that because I used to be a McDonald's employee. And we know that a Shamrock Shake costs $2.49. She is buying one of each for everybody. So what I'm thinking from the start is it would be helpful if we knew the total cost of a Big Mac and a Shamrock Shake put together. So what I'm going to do is I'm going to add $3.59 plus $2.49. I'm going to get a total there. Once I have a total here, I know that she did that for all 96 students. So whatever I get as my answer here, I know that I'm going to multiply by 96, and that should give me a final answer. Now, keep in mind when we're multiplying a decimal, we'll go ahead and do this part together. We had talked about this a little bit in class today. Keep in mind, it's going to be about $6.08 per person. I want to take that and multiply by 96. Something we had talked about when we were, that's a decimal point. Something we had talked about when we were multiplying decimals is if you can get this decimal out by moving it over, keep in mind when we move that decimal over, for every time we move it over, we're multiplying by 10. Because remember, every place value is 10 times larger than the one before it. So if we move it over twice, we've multiplied by 10 twice, which is like multiplying by 100. But the reason I do that is because I think it's easier to work with this whole number here. To do 608 times 96, don't worry about that decimal until the end. And then in the end, because we had multiplied by 100, moved it over twice, we're going to move it back over twice, which would be the opposite of multiplying by 100, which would be dividing by 100. So keep in mind that's a really easy strategy to make it less worrisome to deal with that decimal in that problem, because I know that's something that people struggle with. Now, let me check real fast to make sure. Hi, Robbie. Hi, Luke. Tell Robbie that I said hi as well. So one more thing I want to talk about, if I can get it to come up, is the problem of the week for this week. I've been putting on problems of the week that involve fractions, and this week is no different. I've only had one person attempt this, well, two. One showed me at school this problem so far, and I really want to see, because I think this is one that a lot of you guys could definitely do, and I want a couple of you guys to try this one. So here's what it says. It says, the National Space Board was taking applications for places in the experimental space station city being built near the moon. Half of the applications came from the United States, 1/4 came from Canada, 1/8 came from Japan, 1/16 came from England, 1/32 came from Spain, and 18 applications came from Mexico. How many applications in total have been received for the Space City? Now, this is kind of pretty similar to the word problem that I gave you guys last night about the candy in my car. You may not know how many applications there are, but you do know the fraction for each country. Here would be my suggestion. Try to figure out what fraction is left after you've added all those together. What fraction would be left for Mexico? Once you know what fraction of the total that Mexico is, that problem's actually not too tough to solve. So if you have a question about it, come and ask me, but I really would like to see a few of you guys give that one a shot, because I think it's something that you guys could definitely do. So again, if there is anything else that you guys need to go over, please come ask in class. I'm sorry again for being late, but I'm glad a bunch of you guys came tonight, and I will see you guys at school tomorrow.